Hi, everyone. It's great to be here. My name is Carmen Gomes. I'm an associate professor at Mechanical Engineering Department at Iowa State University. I will be talking about the research and development and nanotechnology related to food and agriculture. And the way I will approach this is as a systems problem, how we can, by doing evaluations in a system level, we can actually ask the right questions and probably come up with innovative ideas to solve the problems. So one of the things that to start with the presentation is about that we all have a shared vision. We wanted to be able to have enough food for feeding the whole world and end hunger. And also we wanted to be able to provide food that is not only related to provide enough nutrition for everyone, but it's healthy and that you can age with good quality of life. And for that, another issue that we would like to achieve is to promote sustainable agricultural practices. So this is part of the sustainable goals, development goals that has been established by the UN. And we all, I believe everybody, if they think about it, they would like to achieve these goals as well. So if you think about health and agriculture, they actually are very well interconnected. And this diagram here kind of describes that. This was put together by USDA, by a program director, Dr. Hong Cheng. And you can see that health and agriculture, the sustainability of both have many aspects and they are similar. And they start from all the way from microbial resistance research, from probiotics activity development and pest management, all the way to food production, crop production, and food at the table. And nanotechnology has a role to play and has been playing a role already over the past 20 years and will continue to do so. And in order to do that, as I mentioned before, we will do a systems approach and to achieve the fourth revolution, industrial revolution. So I got this from the Economic Forum, and it's basically talking about the mindset for the fourth industrial revolution is it's quite different from the previous one, and you should think about systems, not technologies. You should think about empowering instead of just determining what should be done. And you should be thinking about design instead of just default and simple approaches. And you should think about values instead of just a feature and solving a bug. And by connecting the dots that are affecting that particular issue, you actually can achieve innovation and progress. And you can see here that we are migrating more and more to cyber-physical systems. So we don't only cannot think about nanomaterials, nanotechnology, but you need to think about how this is going to interact with computers, with humans, and how this translates into actionable information. So I'll give now an example about feeding the world for the next billion people. And one of the interconnecting dots, which is food waste, and how can we think about a systematic approach to innovate and solve the problems with food wastage. So in this diagram, we start with the biggest challenge, which is food for the next billion. Then you think a little further and you think about that food is not only for feed, but it's also for enjoyment, for health. And finally, you go a step further and think about food for health, how you can age healthy by eating properly and at the same time having pleasure, enjoyment as you do it. And there are many aspects that drive the research in this. And one of them would be food waste. Another one would be health aging, as I mentioned, pleasure. But you also have to think about minimally processed food, food distribution, and so forth. So let's talk about food waste as an example for the systemic approach. So food waste is a major problem, and it's different in different countries. By most developing countries, you can see that food waste, especially regarding fresh fruits and vegetables production, happens at two components of the distribution. At the production side, 14%, and also at the consumption side. And you can see that fresh produce and vegetables are the highest ones in terms of losses. We're talking about 45%. So from time, by the time you end up getting to waste, 45% of everything you produce becomes lost. So how can we probably approach this and try to solve it. And you start asking questions and seeing where technology or innovations could arise. So, for example, in North America, 45% of our fresh producing vegetables are lost during either at production and at consumption level. And one way to do it would be perhaps we can improve the shelf life of that produce. So can we extend that? Can we develop technologies to deal with that? Also, another way to approach it at the consumer side of things would be, can we continue to use the ugly? Can we make them perfect? Or perhaps change our perception and accept that the ugly is still edible? Another way would be disrupting distribution problems that make you lose the vegetables or in the produce while you're trying to transport it to the table. So maybe we can have approaches to better logistics from farm to table directly. And we have seen already some efforts on that side. Another way is to use our parts. So instead of wasting some of the components, we can repurpose. And finally, another level of ideation would be for recall and food safety. Can we make sure that we reduce that? Then we have better traceabilities, better ways to detect contamination, and so forth. Fresh produce and beyond. So can we expand the ways we consume the food? Can we repurpose? Can we, again, use for other ways to consume it and maybe extract the nutrients and nutraceuticals and consume that way? So by reframing, we can break the bottlenecks and shift the paradigm. And if you think about now about the macrosystem, the biggest things that we are trying to accomplish and reduce, for example, the carbon dioxide footprint, there are many things we could start thinking about it and start innovating. One would be understand better food degradation, for example, and other examples are listed there. Detect, control, and connect by developing sensors that become commonplace, that can be used throughout the food supply chain, production, and from production all the way to consumption. Preserve and expand. So can we extend the shelf life of products and so forth? Can we waste less, as I mentioned before? Deliver health and joy. So can we develop new products? Can we manipulate the structure and create new sensations and make food more pleasurable and at the same time healthy? And safe to consumers. So the aspects of consumer opinion, consumer education is very important. We need to make sure that consumers are aware of the technology, so they adopt, they want to use it, they want to be a part of it. And so when we do that, looking at the macro, now shifting to the nano, what nanotechnology can do. So shift to the nano to find the bottlenecks. And see, here are a few examples. As briefly mentioned before, for example, we can change the texture of bread or improve it, such as the texture of bread extends for a longer period of time, or we can genetically modify fresh produce so they last longer, they are pest resistant, and they at the same time don't require pesticides. So looking at the cell level, we can modify things using nanotechnology to manipulate cells. We can also repurpose materials that we don't use to make packaging and make decomposable materials. And in the case of animal nutrition, we can design, for example, delivery systems for better nutrition, for delivery of probiotics, for administration of medicines and so forth. So you preserve the health of the animal and increase yield, for example. So that one example would be by genetically modifying things. And in the case of biosensors, which is an area of research that I work on, I have quite a few points here that I'd like to cover, but for the sake of time, things that we really see the innovation happening, that is a major component that is hindering acceptance by the community, by the societies, that when we design sensors, we should do approach that is use-inspired. So what is the application? And consider the triple bottom line, which means you need to account for the economic, the social, and the environmental aspects of that particular application. And in order for sensors to really merge into society, it will really need to think about interoperability. So from production to distribution to processing all the way to consumption, how this information is communicated. And more, because we think about sustainability, nanotechnology should be thinking about developing materials that are biodegradable. So what I just covered now was about convergence. That's basically the principle of convergence, which is transdisciplinary. It allows us to address individual challenges. And you can see here that we unify in a common question, but eventually we diverge. And that's where innovation and spin-off products occur. So we may not understand all the components of all the connections for this particular question, but with enough connections, we can come up with questions and innovate on that process. So this is another graph that kind of covers the idea of convergence, that we will be in focus and out of focus, going from macro to nano. And by doing that allows us to understand the challenge in different perspectives and come up with innovation ideas for new technology, new materials that to address the issues that we are thinking about. And the success begins with the end in mind. So we need to do the right questions. We need to come up with the right questions. So the scientists should come and start asking the end user, what is the end user, the stakeholders, right? The implementers, the regulators, and the environment. And by asking the right questions, the good questions, you will be able to understand the bottleneck. You will see the benefits for the consumers or the society. You will understand the impacts of safety and environment, and also be able to see if you can make it scalable and efficient. So opportunities abound and challenges are evolving. And you can see here that nanotech has done a lot of impact already, with CRISPR being a commonplace. Now more and more the cyber physical systems aspect of things are becoming more available. Sensors in water quality are also being more and more available for the fresh produce production. And IoT is also gaining major momentum, especially in agriculture. And you'll see Professor Kagan talking more about that. But there are persistent challenges, which is related to the pre-pandemic inequity. We still have a lot of people that don't have enough water, drinking water, and sanitation and food to eat. And post-pandemic, we need to start thinking about not only the energy, food, and water nexus, but the sanitation and the health aspects of things. So to conclude, again, system-level approach allows us to connect the dots, understand their interconnectivity, and come up with questions and innovations to solve those challenges. And we should trust, to final concluding thoughts, we should trust the process and avoid biasing research questions. So ask the questions that are the most granular level and utilize dynamic focus by by zooming in and out of a particular challenge where the proper questions will be arising. And system thinking provides you rich context, so you really can understand the complexity of the problem and allow you to come up with innovative ideas. So I'll stop here, and thank you so much for your time.